Hello and welcome everybody. Today we are doing Trigonometry Lesson 5, and it's our last unit in trigonometry. And up until this point, we have learned all the skills we need for the trig unit. This lesson, we're just putting them all together. So we are looking at determining angles and sides in right angles or right angle triangles. So we will be finding both sides and angles in the same triangle. So in lesson 3, we learned how to calculate the length of a side in a right angle triangle, and in lesson 4, we learned how to calculate the measure of an angle in a right angle using trig. And so we are going to combine both of those, but we're going to start with just a little review. So I will calculate, maybe I'll do one question where we find an angle, and one question where we find a side length. Maybe I'll do C just so we have enough room. Then we will do a word problem together, and then we'll flip the page, and I will show you how to completely solve a right angle triangle. So in the question A here, we have a triangle with one length of 12.7 and the other of 5.2. We are using this angle right here because it says X with a little degree sign. So that is what it's asking us to do, is solve for that angle. So now we have to label the triangle based off of that reference angle. So this side will be our opposite. The side across from the hypotenuse is going to be across from the right angle, is the hypotenuse. I gave away the answer. And the last side will be the adjacent. There's a bit of a lag in my pen, I apologize. So we're trying to find this angle. We are going to use one of our trig ratios. So I'll just write my SOHCAHTOA in the top over here. And so now I have to figure out which two sides I have. Well, I know my opposite and I know my adjacent. So if I'm looking for a trig ratio that has opposite and adjacent, it turns out to be my tan ratio because it has opposite and adjacent. So I can say tan of x is equal to opposite over adjacent. And then I can fill out what I know. So tan of x is equal to my opposite being 12.7 and my adjacent being 5.2. Now, when I'm looking to solve for an angle, I want to use my inverse functions. So that x is going to equal, that angle is going to equal inverse tan. Remember, we use our second function or shift to get there, of 12.7 divided by 5.2. And I type that into my calculator, and what I get, oh here we go. I get, my answer key disappeared on me for a second, 68 degrees. So that means that angle down there is 68 degrees. Okay, so that's solving for an angle. It's the same process. The hardest part of that, well, maybe the two hardest parts, is figuring out which ratio you want to use, because it's an easy one to get mixed up. So make sure you're very thorough in labeling your sides and determining which two sides you are going to use. And then the next part would be just typing in the formula into the calculator properly, typing the equation. And some people will use regular tan, or some people will reverse their numbers, and it can cause some issues. So just be careful with that. The next one is C, where we have this angle here, 69 degrees, and we have one side, and we're looking for a second side. So whenever we're doing trig, we need to have two pieces of information to find a third piece of information. So we have two pieces of information. We have an angle and a side, so that's awesome. And we're looking for a third side. So let's label the triangle. Well, across from our known angle is going to be the opposite. Across from the 90-degree angle is going to be the hypotenuse. And the side between the two angles that we know, or between the reference angle and the 90, is the adjacent. So next step is to figure out which trig ratio we are going to use. So let's see, we have the opposite side and we're looking for the hypotenuse. So we have opposite and hypotenuse. Well, it looks like our sine ratio is going to be correct because we have opposite and hypotenuse. So let's write that in here. Sine of x is equal to opposite over hypotenuse. And now we can plug in the numbers that we know. So now in this case, we know our angle is 69 degrees, so we are going to write that in there. The sine of 69, and then the opposite is 126, and the hypotenuse is x. So we have to do a little bit of algebra now to solve this. So if I have my variable in the bottom of the fraction, I have to multiply both sides by x. And what that does is cancel it out. And then what I'm left with is x multiplied by sine of 69 is equal to 126. Now I want to get x by itself, so I can divide both sides by sine of 69. That will cancel out my sine of 69 on this side, and I'm left with x is equal to 126 divided by sine of 69. And I can type that into my calculator, and I get 135. That means my x is going to be 135. Ask yourself quickly, does that make sense? And it does, right? Our hypotenuse should be longer than both other sides. So 135 is bigger than 126. We're totally good to go. All right, word problems. I think this threw people off a little bit on Friday, so let's talk about it a little bit. The first thing you want to remember is that this whole unit is dealing with right-angled triangles. So when you're drawing your diagram, it's probably going to be a right-angle triangle. Now we have to use the information in the question to figure out which sides we're supposed to be labeling where. So the first one says a telephone pole is 11 meters high or 11 meters tall. I would assume that in my triangle, if there was a telephone pole, it would be right here. So this side would be 11 meters. It is supported by a wire, 13 meters long, fixed to the top of the pole and to the ground. Well, this is probably the ground here. And the top of the pole is probably up here. So if the wire goes from the top of the pole to the ground, and it's 13 meters long, probably that side right there. Also, the wire would be longer because it's the hypotenuse. It says calculate to the nearest degree the angle between the wire and the ground. So the angle formed by the ground and the wire is right there. So what we're looking for is that angle x there. So now we can label our triangle. So across from the x is our opposite side. Across from the right angle is the hypotenuse. The ground is the adjacent. And we can choose our trig function. I'm going to write my SOHCAHTOA right here. So I have my opposite and my hypotenuse. Opposite and hypotenuse is the sine function. Yay! Sine, that's weird. Sine of x is equal to opposite over hypotenuse. And we can plug in what we know. Sine of x is 11 over 13. And then when we are using, or we're trying to find the angle, we use the inverse functions. Right? We know both values of the fractions, so what we want to do is take the inverse sine of the ratio or of the fraction. And if we punch that into our calculator, remember, inverse sine is not the same as normal sine. You have to use your second function button or your shift button before you click the sine button. And on your calculator screen, you should see sine to the -1. And if you do that, we get 58 degrees. So the wire and the ground form an angle of 58 degrees. Then it says calculate the distance to the nearest 0.1 of a meter between the point where the wire is fixed to the ground and the foot of the pole. So they actually want us to calculate this length right here. And it says do this using the Pythagorean theorem and using trig. Well, we know Pythag is a squared plus b squared equals c squared. We have, let's see, this will be we'll leave this one as our a, this side is our b, and our c always has to be the hypotenuse. So we're looking for the a side. So to get the a side, a squared is going to equal c squared minus b squared. So I can plug those values in. 13 squared minus 11 squared. And then my a squared becomes 48. And then we want to figure out what a is, not what a squared is. So I'm going to square root both sides. What that does is it's going to get rid of that squared sign. And now I have a is equal to 6.9 meters. We can also use trig to do this, because if we redraw the triangle from the first part of the question, we knew this side was 11, this side was 13, and that angle was 58 degrees. Just drew it a little bit too small there. So we are looking to solve for the adjacent. So we're looking for the adjacent. We have the opposite and the hypotenuse. So what I think I'll do is use the hypotenuse and the adjacent. I'm looking at my SOHCAHTOA. Hypotenuse and adjacent gives me the cosine ratio. So I can say cosine of x is adjacent over hypotenuse. And I'll plug in what I know. So my angle is 58 degrees. And my adjacent I don't know, but my hypotenuse is 13. So to solve for the adjacent, I want to get it by itself in this equation. I need to multiply by 13 to get rid of the 13 on that side. Multiply that side by 13, cancels out here, and I'm left with 13 multiplied by cos 58 with a. And when I punch that into my calculator, I get 6.9 meters. So either way, it should give you a correct answer. It's good to use trig when you can, the trig ratios. Okay, let's get to the lesson. So today, so we know all of those skills. We've been able to solve for side angles. We've been able to solve for our side lengths and angles, sorry. So now we are going to just learn how to solve right angle triangles, or solve right triangles. So when you see a question that says solve this triangle, it means solve for every angle and every side length. Solve for every angle, every unknown angle, and every unknown side length. And so you are going to be given the same amount of information that you have been given this whole entire unit, but you should be able to solve for everything, which is awesome. So here we go. We've got a good example here. Solve the given triangle. I think this is as far as I'll go. I think you can do the next one, or we'll use the next one for class, whiteboard work in class. Let's solve the given triangle, give all answers correct to the nearest whole number. Well, first thing I want to do is just write down, here are my angles. So I have angle A. So this little sign means angle A, angle B, and angle C. So I know angle B is 90 degrees, angle A is 37 degrees. And then for my sides, I have AB, AC, and BC. So I know AC is 33, and I can find the other ones hopefully. So let's start by finding, and you can start anywhere, but I'm going to start by finding this side, BC. Maybe I'll use green. So for that side, BC. So this is going to be my angle. My angle I use is a reference angle, which means BC is my opposite side. And that means 33 is my hypotenuse. So I have my hypotenuse and I'm looking for opposite. So if I look at my SOHCAHTOA ratios, I have opposite, I'm looking for hypotenuse, or I have hypotenuse, I'm looking for opposite. So hypotenuse and opposite give me a sine ratio. So I can say sine of x is equal to opposite over hypotenuse. And then I'll just plug the information in that I know. Sine of 37 is opposite. Maybe I'll use x because the O looks like, or maybe I'll say side BC over 33. I'll try not to use O because O looks like 0. So in order to solve for BC, I have to multiply both sides by 33. That will cancel out on this side. And I have BC is equal to 33 sine 37. And that would give me C is equal to 20. So now I know BC is 20. And I can label that over here if I'd like to. 20. And it is still our opposite so far. Okay, the next one I want to look at is solving for AB. So I know if I use the same angle, angle 37, that this side is my adjacent. And I'm going to use my hypotenuse. So in this case, I could use this 20 because that is another side, and I could use the tan ratio. But 33 was given to us in the question, so we know that it's correct. 20 we calculated, so we can be very confident that it's correct. But if for some reason we got this answer wrong over here, and then we used the number in the next calculation, then we're going to get that wrong too. So it's always a good idea to use the numbers that the question gave you if you can, because even if you get this 20 wrong, you still have a chance of getting the adjacent correct, if that makes sense. So from my 37, I have my adjacent, and I know my hypotenuse. Adjacent and hypotenuse give me a cos function. So I will say cos of x is adjacent over hypotenuse, and I will fill in the information that I know. So the cos of 37, using the same angle, is equal to, adjacent is AB over hypotenuse, which is 33. And it actually is the same process as the last, as solving for BC. We're going to multiply both sides by 33. That will cancel out. I'm left with AB is equal to 33 cos 37. And when I type that into my calculator, I'm going to get 26. So now I know that my AB side is 26, and I've solved for all the side lengths They make sense because my hypotenuse is 33, and that should be the biggest one, and AB is less than that, and so is BC. And the last thing I need to find is angle C. So I know angle A and I know angle B. So you could do some trigonometry to solve for this, or we can make our lives a lot easier and say that all angles in a triangle should equal what? We talked about this in class, hopefully you remember. All angles in a triangle equal 180 degrees. So we can say if they all equal 180, I can subtract the 90, that's angle B, and I can subtract 37, which is angle A, and that will give me angle C. So 180 minus 90 minus 37 is 53 degrees. 53 degrees. There we go. Those are the answers right there. We have solved the triangle. Yay! Let's put that in there. 53 degrees. Fantastic. If you want, try this one down here. You start with 2 side lengths and no angles, which is fun, but very doable, and you know how to do it. You have the skills. So give it a go. Thanks for watching. Don't forget to like and subscribe.